Let's continue the discussion about extrema. So we're going to go back here with local, but still work a little bit with absolute. So we have a new test, and I'm going to compare it with the test that we already know. This is called the second derivative test for local extrema. And the test is pretty straightforward. It tells you that if you have a critical number such that the first derivative is 0, or actually that it should say that it's undefined. I'm going to add this here, as long as it's a critical number. Then the way that the test works is that if you plug in the critical number into the second derivative and it's positive, then it's a local minimum. And if you plug it into the second derivative and it's negative, and it's a maximum. So it goes the opposite direction. Positive means min, negative means max, which is kind of like the opposite of what you think it would be. And then it's a small note, which I'm going to show in an example. If you are in an open interval and only one critical number exists, that local max or min becomes an absolute max or min. And in the previous video, we had discussed how the local can actually be the absolute, and this is going to be in a situation that it can be. Okay, so we have a polynomial, and we want to find the local extrema, and I'm going to compare with what we used to do, and now with this new thing you can do. So the old way we used to test for local extrema is we used to find the derivative, because remember, your local extrema still come from your critical numbers, which is your first derivative. So no matter what, you're still going to have to use your first derivative. So we have 3x squared minus 18x plus 24. And then we say, when is it 0? When is it undefined? So for when it's 0, I'm going to pull out a 3. I'm going to have x squared minus 6x plus 8 is equal to 0. That's going to factor nicely for me into an x minus 4 and an x minus 2. And so I get x is equal to 4 and x is equal to 2. And then it's never undefined because it's a polynomial. Now, because the critical numbers, the partition numbers are part of the domain, then they're both critical numbers. And so now this is how we test it. So whether or not you use the first derivative test or the second derivative test, you're going to start the same way. So I would still have this here. All right, you're going to do the exact same thing. What changes is how you test them. So in the first derivative test, we created a little sign chart. And then we picked like negative, well, actually 0, 3, and 5. And we tested it in the first derivative. So when I plug in 0, I'm going to have a negative times a negative, which will be a positive. When I plug in 3, I will have a negative times a positive, which is negative. And when I plug in 4, I'll have 2 positives. And because I increased, and then I decreased, and then I increased, I knew that 2 was a max, and that 4 was a min. Now, the new way to test it, the second derivative test, is instead of drawing a sign chart, you find the second derivative, which will be 6x minus 18, and you plug in the critical numbers into the second derivative. So when you plug in 2, you get 12 minus 18, which it will be a negative 6, but you don't actually care what the number is, you just care that it's negative. And when you plug in 4, it will give you 24 minus 18, which will be a positive 6, so it will be less than 0. So because it's negative, it's a max, and because it's positive, it's a min. And so this is the difference in testing. It'll give you the same answer. Now remember, you still have to find the y's. So I still need to, no matter which test you use, we still need to do f of 2 and f of 4. And again, where do we test them? We test them in the original function. So when I plug in 2, I'll get 8 minus 9 times 4 is 36, plus 24 times 2 is 48, minus 10. All right, so again, just be careful. I know you're using a lot of different functions, so sometimes it's a little tricky too. Okay, so 8 minus 36 plus 48 minus 10 is going to give us a 10. And when I plug in 4 is 64 minus, I'm going to have 9 times 16, which is going to give us 144, plus 24 times 4, 96, minus 10. So I have a 64 minus 144 plus 96 minus 10, which will give us a 6. So I have a local max at 2, 10, and a local min at 4, 6. So a very common question, which is normal, is, well, which one should I use when? And if it doesn't specify, you can use it whichever one you want. My go-to is normally that if the second derivative is easy to find, then I use the second derivative test because I think it's faster than the sign chart. However, if your second derivative is 0, then it's inconclusive and you still need to do the sign chart. So just keep that in mind. Okay, so let's look at this one. Find the absolute extrema of f of x is equal to 12 minus x minus 5 over x. So because I'm having the word extrema, I know for sure that I need to find my critical numbers. So I have f prime of x is equal to 0 minus 1. Now, here I have to change this to a negative 5x to the negative 1. Otherwise, I can't take the derivative. And that's going to become a positive 5x to the negative 2. I'm going to rewrite it as negative 1 plus 5 over x squared. So when is it 0? When is it undefined? So I have negative 1 plus 5 over x squared is equal to 0. That gives me that negative 1 is equal to 5, negative 5 over x squared. I bring the denominator over. I'm going to erase this for a second. I'll come back to it. I'll have a negative x squared is equal to a negative 5, which means that x squared is equal to 5, which means that x is equal to plus or minus the square root of 5. Now, when is it undefined? Well, it's going to be undefined anytime the denominator is 0, which means that x is equal to 0. But you need to pay attention to your interval. I'm specifically on 0 to infinity. So I'm actually going to rewrite this separately. I'm going to rewrite it as negative square root of 5 and positive square root of 5. So because I'm 0 to infinity and 0 has an open parentheses, it means 0 is not included. So 0 is not included and negative square root of 5 is not included because it's no negative number. So I only have one critical number. So when you only have one critical number on an open interval, you can use this little note at the bottom, which is that if you figure out it's a local max or min, it will become an absolute max or min because it's the only critical number. So I just need to figure out if it's a local max or min. And I'm going to do that by using the second derivative test just to get a little bit more work with it. So I'm going to find the second derivative. So the derivative of negative 1 is 0. And then 5x to the negative 2, I'm going to bring down the negative 2, negative 10, x to the negative 3, which is negative 10 over x cubed. And then I'm going to plug in the square root of 5. So I'm going to have negative 10 over the square root of 5 cubed. And again, I don't need a calculator for that because I don't care what the number is. I just care whether it's positive or negative. So it's a negative 10 over a positive number, so it will be at less than 0, which means it's a max. And because it's the only max, it becomes a absolute max. So the last thing is I need to find the y for it. So f of square root of 5. I'm going to have 12 minus the square root of 5 minus 5 over the square root of 5. So just be careful with that when you're doing that. So that's going to give us approximately 7.5. You have to have a decimal because the square root of 5 is irrational. So we're going to round it to the nearest tenth. So we have an absolute max at 7.5 when x is equal to the square root of 5. Okay. Let's look at the next one. We're going to, let me highlight this. Okay, given the total cost of producing Q units of a certain commodity, find the average cost. All right, so we haven't done that in a while, so let's do that first. So average cost is when you put a little line at the top, and average means that you take the total cost and you divide it by how many units you have. So if we do that, it gives us 3Q squared plus 3Q plus 75 over Q. Okay. Determine the level of production at which the average cost is minimized. Okay, so if you want to find minimums, and this is going to be something that we do a lot starting from now, is we need to find the local extrema or the absolute extrema, which means that we have to find the first derivative. So to find the first derivative of the average cost function, you're going to be able to do it in two ways. The first way is you can use the quotient rule. The second way, which is what I'm going to do because I think it's faster, is because there's only one q at the bottom, I can actually separate this and divide it into each of them. And then I can simplify, which will give me 3q plus 3 plus 75 over q, but I'm actually going to rewrite it as 75q to the negative 1 because I'm going to want to take the derivative. So then I have c, the average cost derivative, c prime with the line on the top, 3 minus 75q to the negative 2, which is 3 minus 75 over q squared. So when is it 0? Oh, I almost wrote f. So when is it 0? When is it undefined? So 3 minus 75 over q squared is equal to 0. 3 is equal to 75 over q squared. 3q squared is equal to 75. Q squared is equal to 25. Q is equal to negative 5 and 5. When is it undefined? Well, the q is at the bottom, so again, q cannot be 0. However, here, you are in a real-world situation. You're in the situation where you're making units. So you can't be making negative units. So immediately the negative 5 is out. And the average cost, because they had q at the bottom, you already knew that q couldn't be 0. So this is out. So we only have one critical number, which is q is equal to 5, which means that on the interval, this local, because it's the only critical number, is going to become absolute. So how do we know which one it's going to be? Well, again, that's up to, you can check it using the first derivative test or the second one. I'm going to use the second one because practice, and this is what we're learning. So I'm going to take it from here. The derivative of 3 is 0. Then I'm going to have 150 q to the negative 3, which is 150 over q cubed. And then I'm going to plug it in. I'm going to plug in 5. And I can already see that when I plug in 5, it's going to be a positive 150 and a positive 125 in the bottom. So it's going to be greater than 0, which means it's going to be a min, which is exactly what I was looking for. And the question asks, determine the level of production at which the average cost is minimized. So I don't have to find the cost. They just wanted to know what q is, and I already found that. It's q is equal to 5. So q is equal to 5. If you wanted to, again, you could have done a sign chart to test whether it was a min or a max. So that is up to you, but I wanted to practice the second derivative test.